Hello guys, so we are back again, and in this session we are going to continue with the Cauchy differential equation, which was type 9th. So in this Cauchy differential equation we have done two problems and we understood the whole theory and how to solve the Cauchy differential equation, complete knowledge. Now we are going to take some more questions and understand it more clearly by taking more examples. So the third question which we are going to take is this one: x cube d cube y by dx cube plus 3x square d square y by dx square plus x dy by dx plus y equal to x plus log x. Right? Now to solve this problem, I will not going to write all the statements. I am just going to write whatever is important. So the given differential equation is a Cauchy differential equation. We will use the x equals to e to the power z. Okay, I will just write that thing, e to the power z, which will give us that dz by dx is nothing but 1 by x in the end when you move log x here, or you can say after this step. After this you will come to know that dy by dx is nothing but dy, x dy by dx is nothing but this, and x square d square y by dx square is nothing but d into d minus 1 into y. And similarly you will prove that d cube into d cube, x cube into d cube into d cube y into dx cube is nothing but d into d minus 1 into d minus 2 into y. After proving these three, you will move on and substitute this in the given differential equation and try to get the answer. So if we substitute the things, we have d into d minus 1 into d minus 2 into y first here, then 3. If I substitute this, d into d minus 1 into y, and if I substitute this here, I will have d into y plus y equal to, here I will substitute instead of x e to the power z, and instead of log x I will substitute z, so e plus z. If I simplify, I will get an equation which will be very simplified, and you can, if you solve this and take y common, you will be left with d cube plus 1 into y e to the power z plus z. After this we are going to focus on auxiliary equation. Auxiliary equation is m cube plus 1 equal to 0, which you can open it by a cube plus b cube, which is a plus b into a square minus ab plus b square. So you will get a equals to minus 1 and other will be complex, which will be 1 by 2 plus minus iota root 3 by 2. If you move on getting a complementary function, you will get a complementary function cf as c1 e to the power minus z for this one, and further on you will have e to the power minus z by 2 into c2 cos root 3 by 2 into z plus c3 sin root 3 by 2 z. Now you know in your complementary function, when you write the general solution should be in terms of x, not in terms of z, while when you convert the Cauchy differential equation into the higher order differential equation with constant coefficient, you have to have no x. So if I want to, we have to replace this. So if I replace c1 x power minus 1 plus, it will be under root x e to the power z is, and here it will be power 1 by 2. E to the power z is what? X, so it will be under root x. Here c2 cos root 3 by 2 into log x plus c3 sin root 3 by 2 log x. Agree? Now we are going to take the next page. So here what we are going to focus on, we are focused on getting the complementary function, particular integral. Particular integral will be 1 by d cube plus 1 into e to the power z plus z. If you multiply this, 1 by d cube plus 1 into e to the power z plus 1 by d cube plus 1 into z. You can treat them separate integrals or you can treat them single one, it's up to you. Now in this type what we do, we directly substitute. So we will have 1 cube plus 1 into e to the power z, while here we use the polynomial expansion. So what we are going to do, we are going to take the possible lowest one. So we are going to first write it in 1 upon 1 plus x or 1 upon 1 minus x format. So here it will be this. If I arrange this in this format, I can substitute, then I will have e to the power z by 2 here, and I have to simplify this. Here it is 1 upon 1 plus x, so by Maclaurin series of expansion of 1 upon 1 plus x, I will write 1 minus d cube and so on. Because my polynomial is only of power 1, so I'm going to stop. I'm not going to consider this one also. I will have my final answer ez by 2 plus z. Now I have to resubstitute the things. E by z is nothing but x and z is nothing but log x. So I got my particular integral. My general solution is a combination of complementary function plus particular integral, right? I know my complementary function from here, so I will substitute the things. C1 x power minus 1 plus under root x, C2 cos root 3 by 2 log x plus C3 sin root 3 by 2 log x plus particular integral, which will be nothing but, in this case it will be x by 2 plus log x. So we are done with this problem. Hope you have understand each and everything. So now let's move on to the next problem. The next problem which we are going to take is nothing but this problem. So the problem is like this. So here in this problem, x square d square y by dx square plus 5x dy by dx plus 3y equal to 1 plus 1 by x the whole square log x is given. So what we are going to do, the given differential equation is a Cauchy differential equation. First line, after that you know you have to substitute x equals to e to the power z, then we will have log x equals to z. After that you will get the value of dy by dx, x dy by dx, which will be nothing but d into y. Similarly you will find the value of x square d square y by dx square. You will get the value d into d minus 1 into y. After doing all this stuff, you are going to focus on getting this Cauchy differential equation into higher order differential equation with constant coefficient, which will be d into d minus 1 into y plus 5 into dy plus 3 into y equal to, you are going to substitute the values 1 plus 1 by e to the power z for x, and for log x it will be nothing but straightforward z. Now if I expand this one and try to, I will write it as 1 plus e to the power minus z, then its expansion will become easy, and here I will have final answer d square plus 4d plus 3 into y. And here if I write, okay, this I will write as 1 plus e to the power minus z the whole square into z. If I open this, I will have z plus I have multiplied also, 1 plus 2 e to the power minus z plus e to the power minus 2z into z. Agree? I will multiply this with each of them. So I will let z plus 2 e to the power minus z, 2 e to the power minus z plus z e to the power minus 2z. Agree? And on the right side d square plus 4d plus 3 into y. So we are having this thing. Now if I focus on getting the auxiliary equation is nothing but m square plus 4m plus 3 equal to 0, and if you open out you will get m equals to minus 3 and minus 1 as the roots. So complementary function is very easy. It is nothing but c1 e to the power minus z plus c2 e to the power minus 3z. Now if I convert them into the x term, because when I write the general solution I should have everything in terms of x, so I will substitute the thing c1 x power minus 1 plus c2 x power minus 3. Just replace e by z as x and keep the power as it is. After this I will focus on getting the particular integral, which will be 1 upon d square plus 4d plus 3 into z plus 2 e to the power minus z plus z into e to the power minus 2z. Agree? I will multiply with each of them and try to get my answer. Now let's do it. So I will have, firstly I will have d square plus 4d plus 3 into z. Secondly I have 2 upon d square plus 4d plus 3 into e to the power minus z into z plus 1 upon d square plus 4d plus 3 into e to the power minus 2z into z. Just keep it as 1. Now what we are going to do, we are going to, you know this is a polynomial type, so we are going to use the Maclaurin series of expansions to solve this. Let's consider it as I1. So if I consider it as I1, it will be, agree, take the 3 outside, right? We are left with this into z. Use the Maclaurin series of expansion. We are getting this, and after this it will be greater than, so we are going to stop after this. We are left with 1 by 3 into z minus 4 by 3 d into z. Agree? So what we are going to get finally, we are going to get something like z by 3 minus its differentiation will become 1 and it will be 4 by 9. If I resubstitute, okay, for the timing I will keep it as it is and call it as A. So my I1 is this, consider I2. 2 by d square plus 4d plus 3 e to the power minus z into z. When you move this that side, it is of type e to the power x into v. You will have to replace d by d minus 1 the whole square into 4d minus 1 plus 3. After this you are left with this and it will become polynomial type. So if we simplify this, we are going to left with 2 e to the power minus z will be as it is, okay, and what we are going to have, if there was 2 or not, I have some doubt, there was 2 or not. When we write this integral, there is 2, this 2 I will keep as it is, and here if I substitute and simplify, I will be left with d square plus 2d into z. If you simplify this, you will get this. Now minus z, I will use the Maclaurin series of expansion, take 2d common, which will give me 1 plus d by 2 into z. If I do the expansion, e to the power minus z, here 2d will be as it is, and here 1 minus d by 2, right, will be given, and after this we will not consider because it will become square and we won't see power of only 1. So finally we have 2 e to the power minus z by 2d, 2 will get cancelled out, and here z minus 1 by 2 because its differential will become 1. After this, what we are going to focus, this 2 got cancelled out and we are going to integrate this. So if I integrate this thing, I will be left with z square by 2 minus z by 2. Agree? So we are getting this thing in the end. Now we are going to resubstitute. Okay, till the timing, let's keep the thing as it is. So this is our B. Now consider the I3. Consider I3. If we consider I3, what we are going to left with is something like d square plus 4d plus 3 into e to the power minus 2z into z. Agree? So we are going to simplify this. So if we focus on simplifying this, when I move it on that side, e to the power minus 2z, I am going to replace d by d minus 2 the whole square plus 4, replace d by d minus 2. If I simplify this, I am going to left with e minus 2z 1 upon, here it will be d square minus 1 into z, and here what we are going to take, we are going to take minus outside because it should be a format of 1 minus x or 1 upon 1 plus x to apply the Maclaurin series. So e to the power minus 2z, take the minus outside, we are left with 1 minus d square into z. Apply the Maclaurin series, e to the power minus 2z, here it will be 1 plus d square, and after this we cannot take only, so e to the power minus 2z, we will not consider this also because the power should be what, only 1, so it will be z. So we are getting this as our answer, final answer, so I will call it as C. If I substitute all the things in 1, put A, B, C in 1, what I am going to get? I am going to get firstly z by 3 minus 4 by 9. Secondly, I am going to get plus e to the power minus z, z square by 2 minus z by 2. Thirdly, minus e to the power minus 2z into z. I know my final answer should be in terms of x, so what my aim will be, I am going to resubstitute the things. The moment I resubstitute, I should know what I am going to resubstitute. Instead of z, I am going to resubstitute log x, so log x by 3 minus 4 by 9 e to the power will be x minus 1. Here it will be log x the whole square by 2 minus log x by 2. Here it will be minus x power minus 2 into log x. So this is your required thing. Agreed? So we are getting this thing. Now your general solution is a combination of complementary function plus particular integral. Agreed? So we are going to substitute the things whatever we have. So let's just substitute the complementary function, which was c1 x power minus 1 plus c2 x power minus 3, and then particular integral log x by 3 minus 4 by 9 plus x power minus 1 into log x the whole square by 2 minus log x by 2 bracket close minus x minus 2 into log x. So this is our required general solution. Hope you have understand each and everything. Now let's move on to the next question. This question was a bit lengthy because here 3 integral got involved, so it's quite bit time consuming, and if they ask this type of question, it will be 5 marks or 10 marks. You can expect 8 or 10 marks. If the paper is of 60 marks, then it will be 5 to 6, but if the marks is of 100 marks, then it will be 10 probably. Now let's move on to the next question. The next question which we are going to take is this question, which is this: x square d square y by dx square minus 3x dy by dx plus y equal to sine bracket log x plus 1 by x. So the given differential equation is a Cauchy differential equation. You will substitute x equals to z e to the power z, giving you log x equals to z. If you substitute, you will get x dy by dx as nothing but dy, and similarly you can prove d square y by dx square as nothing but, you will prove it to be equal to d into d minus 1 into y. Just resubstitute the things here. So d into d minus 1 into y minus 3 into d into y plus y. Here it will be sine z plus 1 upon e to the power z. Agreed? So after this, what we are going to do? We are going to simplify the equation. We are going to move this e to the power z in the top, which will become e to the power minus z. And if we simplify this, we will be left with d square minus 4d plus 1 into y. Here e to the power minus z into sine z plus e to the power minus z. Complementary function is very easy. Okay, but before that, let's get the auxiliary. Auxiliary equation is nothing but m square minus 4m plus 1 equal to 0, which here we can make out that our m will be imaginary. So m value will come out to be 2. No, not imaginary. Okay, it's irrational. So it is 2 plus minus root 3. So our complementary function will come out to be c1 e to the power 2 plus root 3 z firstly, and the second c2 e to the power 2 minus root 3 z. Agreed? And then we know our final answer should be in terms of x. So I'm going to replace this c1 x to the power 2 plus root 3, and here c2 x to the power 2 minus root 3. So this is our final answer of complementary function. Now let's get the particular integral. Particular integral will be what? 1 by d square minus 4d plus 1 into e to the power minus z sin z plus e to the power minus z. Agreed? Now let's multiply with each of them and try to get what is our required answer. So we will have two integrals here. First is d square minus 4d plus 1 e to the power minus z sin z, and secondly 1 by d square minus 4d plus 1 e to the power minus z. This one is very easy compared to any of them. Okay, here if we consider I1, this is I1, consider I1, we will substitute, we will take this on right side. Like if we take this right side, we will substitute, replace d by d minus 1 the whole d minus 1. This will become plus 1 e to the power minus z into sin z. So this was of the type e to the power ax into v. So what we are going to do, we are going to simplify this, and when we simplify this, what we are going to left with e to the power minus z 1 upon, we will be left with d square minus 6d plus 6 into sin z. And when we know in the f of d equals to format of sin ax plus b, we used to replace d square by minus a square. So what we are going to do, we are going to replace here by minus a, which will make this 5 minus 6d minus z 1 upon 5 minus 6d into sin z, and after this we will rationalize this e to the power minus z. Here it will be 5 plus 6d the whole upon, after rationalizing it will be 25 minus 36d square, agreed, into sin z. Further on, if we substitute again, I am going to left with 5 plus 6d the whole upon, this will become plus, so it will add on, and which will give become 25 plus 36, which will be nothing but 61 into sin z. Now this will move aside with e to the power minus z by 61, and this will be 5 sin z plus 6d sin z. So if I differentiate the sin z, my final answer will be 5 sin z into 6 cos z, agreed. So this is my A, and this is my equation 1, where I will substitute all the values. Now let's consider I2. If I consider it I2, I am going to have d square minus 4d plus 1 e to the power minus z. I am straightforward going to substitute minus 1 in place of d, which will give me my final answer as 1 by 6 e to the power minus z. I will call it as b. I will substitute everything in my first equation, which will give me e to the power minus z by 61, 5 sin z plus 6 cos z, and plus 1 by 6 e to the power minus z. Now I am going to resubstitute the z, so which will give me, I have to substitute e to the power minus e to the power z by x, so x minus 1 by 61, 5 sin log x plus 6 cos log x bracket close plus 1 by 6 x to the power minus 1. So this is our required I1 and I2. So we got our particular integral. This is our particular integral. We just substituted a and b in the one. Okay, here we substituted, this was our particular integral thing, which was our a and b. We have substituted and got this, and then resubstituted and got the final particular integral. General solution is a combination of complementary function plus particular integral. So if you write if you try to write this complementary function, it will be c1 x power 2 plus root 3 plus c2 x power 2 minus root 3. Then particular integral will be x power minus 1 by 61 into 5 sin log x, right, plus 6 cos log x bracket close plus x power minus 1 by 6. So this is our required answer. Hope you have understand each and every problem. So now let's move on to the next lecture and solve more problems in the next lecture. But the next lecture will be the last lecture on Cauchy differential equation. After this we will move on to legendary differential equation, which is nothing but a little bit modification of this only. So practice these problems and see you in the next session. Okay, bye.